This video is for using triangle similarity theorems to solve problems. These notes are for lesson 4.12. So we're going to do angle-angle similarity. Alright, so state whether the triangles in the figure below are similar and complete the similarity statement. So the triangles in the figure are similar because of A similarity. Okay, so these marks help us. And one of the marks is already given to us. Angle S and angle C is already given to us. That one little mark there and that one little mark there says those two are congruent. So we know angle S is congruent to angle C. Angle D is congruent to itself, so this angle right here, these are vertical angles. So we know these two pieces of the triangle are congruent, so just angle D, it's labeled the same. And then that means, so angle-angle similarity says that if two triangles have two angles in common, then that automatically means that the third angle, which is angle P and angle R, are congruent. So SDP is similar to CDR. That's the big triangle. So now we're going to use angle-angle similarity to find the length of the missing side in the figure below. So again, we know that these are similar triangles because these two match. These two are vertical angles, which automatically means these are in common. But we have to match up the sides. So first we've got GZ. So GZ is this one. So from the center out. So we're going from the center to the angle that doesn't have a label in the corner. So we have to do the same over here. GZ is going to be similar to oh, it already has it here, GY, sorry. There's its pair. So now we need to find another pair. So since we've got GZ on the top, that's this big triangle, we need another side from this big triangle. And we want the side that's labeled, and that side is ZB. Okay, now ZB goes from the non-marked to the marked, so it matches up with the little triangle from Y to S. And now we can fill in the values. So GZ is 14, GY is 6, ZB is 16, and then YS is our unknown. So to solve this, we cross multiply and then we divide. It's just like tic-tac-toe, and you can set up a tic-tac-toe board for these as well, if that helps you keep everything straight. So if we do that, 6 times 16 divided by 14, move this over here. So 6 times 16 divided by 14, we get 48 over 7, and it is okay to leave it in that form. We could make it a decimal if we wanted to kind of have a estimate of about the measurement, but this is the most exact form. Okay, so the next one we're going to do is side, side, side similarity. So state whether the triangles in the figure below are similar and complete the similarity statement. So the triangles in the figure are similar because of side, side, side similarity. Alright, so the ratios here. ZX is going to correspond with ZG. And I apologize that these blanks are so small here. ZG. Okay, so ZX is 17. ZG is 51. Now I'm going to simplify that fraction down. So 17 over 51 simplifies to a third. When I simplify that fraction, it makes it easier to compare. All right, XY, that's this side, is going to be similar to GN. So XY is 31, GN is 93. So 31 over 93 simplifies to a third as well. And all that is, that's not the measure of this side, it's the ratio or the proportion between the two sides. And then YZ matches up with NZ. So YZ is 27, NZ is 81. Check that fraction one more time. And that's why you need to simplify fractions, because if you don't, it's hard to tell that they all have that corresponding ratio. Okay, so now we're going to use the side similarity to find the length of the missing side in the figure. So BD matches up with HX, and then we need another given side. Okay, so we're going to use, we're looking for, what side are we looking for? We're looking for YX. We're looking for this length here. So YX is on the big triangle, and we've got the big triangle on the bottom here. So this is the small triangle sides. This is the big triangle sides on the bottom of each ratio. So YX matches up with YD on the little triangle. So BD measures 40, HX measures 160, YD measures 27, and then YX is what we're looking for. So we cross multiply and then divide. Don't use the X, just use the numbers when you cross multiply and divide. So 160 times 27 divided by 40 gives me 108. So this side would measure 108. All right, last one down here is going to be side angle side similarity. So state whether the triangles in the figure below are similar and complete the similarity statement. So the triangles in the figure are similar because of side angle side similarity. So now we need to match up. So GHJ goes with ZXY. See how I follow the same pattern? So H, the one that's marked, is in the middle, which means X over here needs to be in the middle. So you have to match up the pieces when you make a similarity statement. All right, so angle H matches up with angle X. GH matches up with ZX. HJ matches up with XY. And JG matches up with YZ. And I know that based off of the sides and the ratios here. 6 times 2 makes 12. 13 times 2 makes 26. So I know these are pairs and these are pairs, which means these two sides have to be pairs. Sometimes they're turned, sometimes they're not sitting in the same position. All right, so use side angle side similarity to find the length of the missing side in the figure below. Okay, so again, we have to match up here. So AC is this one here. C and J are buddies in this. So we know side J is going to have to be involved. Okay, so is it going to be JK or JL? So sometimes these get a little tough. In this one, it's JL, or sorry, JK. I'm sorry. AC goes with KJ or JK. And then CB goes with JL. So that one's been flipped around for us. And sometimes you have to redraw. So AC is 6. Okay. Let's see. CB is 8. And that's where I'm pulling the numbers from. AC is 6. CB is 8. KJ is X. JL is 10. And then we cross multiply and then divide. So 10 times 6 times 6 divided by 8 gives me 15 over 2. So again, 15 over 2. This one is a nice decimal. So for this one, I'm okay with putting 7.5 because it's a terminating decimal. It ends. It doesn't repeat forever and ever. So that's it for this set of notes.